So everything gets divided by 3. And now I've got, so in order to complete the square, the leading coefficient has to be 1. All right, so that's how these 2 steps here is how we got the leading coefficient to 1. All right, and then it's the same process as yesterday. Okay, now just some vocabulary here when we're talking about terms. Okay, the term with the square on it, that is your quadratic term or your squared term. The term that has the x on it is referred to as your linear term. And then the term that has no variable on it is known as your constant. Okay, now the values of A, B, and C are just the coefficients. So A is the coefficient of the quadratic term. It doesn't include any of the x's. Then B is the coefficient of the term that just has an x in it. And C is the constant. So the linear term or the coefficient here is not 12x, it's just 12. All right, and then our rule is take half of B, which is 2, and then square it, and you get 4. And that's how you create something that can be factored. So it's always B divided by 2 squared. All right, and now it's just a matter of factoring it. This is a perfect square trinomial. So it's always going to factor into, it'll never be 2 separate binomials. So x, and then what multiplies together to be 4 and adds together to be 4, 2. So when it says factorize the perfect square trinomial, that's this guy right here. Okay, and now solve it. So to solve this, remember when there was one term, we could use the square root method. That's this one right here that we did earlier. So we're just going to take the square root of both sides. Squaring and square rooting undo each other, so we're just left with x plus 2. And the square root of 10, you can't simplify it, so it's the positive root 10 and negative root 10. So if we needed the decimals, we'd go -2 plus root 10 on our calculator and -2 minus root 10 on our calculator. And that would give us the decimal equivalence of that. This is the exact solution. When you don't do the decimal, you just leave it as a radical. That is your exact definition or your exact solution. Okay, so if I wanted to know what that number is as an actual value, it's plus second square root 10. Okay, so that x-intercept is around 5. And it's -2. That's wrong. Okay, so -2 plus 2 minus second. And that's the two x-intercepts as decimals. Okay, so the last one is really no different, except that you run into the way you simplify the answers a little different. That's all. Everything else is the same. Okay, so whether you add the constant before you divide by 4 or after, it doesn't matter. Okay, so I typically move it before, but it really and everything's going to get divided by 4. So the only thing that makes this example any different, whoops, is you got some fractions. Okay, coefficient on x is -2, so I do half of -2. Now that 1, so that I can add these, I'm really going to think of that 1 as a 2/2. So I can add it to 3/2 and get 5/2. And this guy over here, perfect square trinomial, minus. And then all you're doing is, it's whatever this number is. Okay? The square root of 1, or you can do the square root of this term. And all right, and now it's just how do you simplify these radicals? Okay, so I got x minus 1 equals, okay, simplifying the square root of a fraction. Okay, a couple of ways you can do it. If the bottom's a perfect square, you can just separate it. So if I had something like this, 5/9, then I could do that. And I'd end up with √5/3. Okay, 2's not a perfect square. So if I try to do this, I'm going to get a radical in the denominator. And we want to avoid having radicals in the denominator. We want to have just plain numbers. All right, so what you can do ahead of doing that is change this so that the denominator is a perfect square. So if I took the denominator and I multiplied it by 2, it would be a perfect square. So whatever I do to the bottom, I do to the top. And this gives me 10 over 4. And now when I split that, I get root 10 over 2. So 10 over 2, and I've got a positive version and a negative version. Okay, now how you write the answer here usually confuses folks. Let me show you this. Add 1. Okay, so my answer would be 1 plus or minus root 10 over 2. And you can leave it like that. That's fine. Now, if you look over here, it says the answer can also be written as 2 plus or minus root 10 over 2. Okay, the way that one was arrived at is you take this 1 and you turn it into a fraction. Now you can add those two fractions. You get 2 plus or minus root 10 over 2. Just adding the numerators because the denominators are the same. Both of these are the same answer. Doesn't matter the way you write it. Okay. All right. So this next example that we're doing is going to be using completing the square to find the equilibrium point on a demand and supply curve. Okay. All right. So let's see. Switch to this screen. Okay. So a lot of you guys, I saw you're all in UConn. So your there's two laws, demand and supply, right? Okay. So your law of demand is pretty simple. Price goes up, demand goes down. So they're inverses of each other. That means if this decreased, this would increase. Okay. So that's called an inverse relationship. Okay, as one goes up, the other goes down, or vice versa. Okay. Now the law of supply is just the reverse. It's not inverse. So if one goes up, the other one goes up. So the law of supply means as price increases, whoever's making the item is going to be encouraged to make more of the item. Is that correct? Okay. You guys correct me if I'm wrong. Okay. So as price goes up, the manufacturer or the supplier is going to be encouraged to increase supply. We got more money coming in. All right. So here are two curves. In econ, we draw a supply and demand curve. We're basing it, let's say, on the price of gasoline. Okay. The supply and the demand are based on the price, which in mathematics means you put the price on the x-axis. Price is the independent variable, and the quantity is the dependent variables. So x is independent, y is dependent. But economists don't do it that way. They do it the reverse. So economists put independent variable on the y-axis and the dependent variable on the x-axis. It's just the reverse of how we normally would graph in a math class. Okay, all right, so when you're looking at a supply and demand curve, you look at the demand. All right, here, if I was looking at a point, let's say right here, I was looking at this price. I'm just going to make up a price, say $3. Okay, if I go over to when it touches that red graph, that's the demand graph. Okay, then this would be the quantity demanded. Okay, what people are willing to spend. Let's say that was gasoline. Okay, so let's make this equal. Let's say gas went up to like $4 a gallon. Okay, if gas goes up to $4 a gallon, the demand for it is going to go down because people aren't going to want to spend $4 a gallon. They're going to try to find ways to not buy as much gas. Carpool, ride the bus, ride a bike, stuff like that. Don't take trips if they don't need to. So the quantity goes down. Okay, now the amount supplied at the same time, throw this going over, where it hits the supply curve, down here, that's going to be the quantity supplied. Because oil companies are making all sorts of money to be able to increase the supply. Okay, demand is really low. So how do you find that's a surplus or a shortage? How do you, it's a surplus because, right, so quantity supplied is a lot bigger than quantity demanded. So this part of the graph represents surplus. Okay. All right. Now, the part where the two graphs meet, okay, that's when the quantity, the price, that would be the price where the quantity demanded and the quantity supplied are equal. That's what's called equilibrium. When the amount supplied is equal to the amount demanded. Okay? And now if you went below that, so if gas went down to like 50 cents a gallon, I remember like when it was 25 cents. Yeah, 25 cents a gallon. Yeah, 20 gallons. $5. Okay, so now, if I draw lines coming over here, go down, that's where it gets, that's the quantity supplied. That's the quantity demanded. Okay, so now this is further along than that. So the quantity demanded is greater than the quantity supplied. That's when you got really long lines at the gas station. So that's when you have shortage. So that's your shortage, and this is your surplus. And where the two graphs meet, that's your equilibrium. Does gas ever go bad? Yeah, it gets water in it. Like gas in your, you had a car sitting for a long time. Gas tends to absorb moisture, or if like left in your lawnmower, you try to start it. I think it eventually it still absorbs moisture. I don't know if it's got like a light, I would imagine it's got light. Okay, now if we switch the two, okay, so now price is here. So here would be your equilibrium price. So here, quantity supply equals quantity demanded. All right, now on this graph over here, our surpluses were this section of the graph, and the shortages were in this section. Now, how about over here? Okay, so let's do a price. This would be a price above equilibrium. So if I drew that, this would be the quantity up. This would be the quantity supply. Okay, so at this price, yeah, surplus or shortage. Yeah, so now the surplus is represented by this part of the graph. And your shortage would be this part of the graph. Because we switched X and Y, we switched. Okay. So here's the price below the equilibrium. Price there. Quantity quantity supplied. Now demand is greater than supply. So now this section of your graph represents. So when we draw the graph on Desmos here, you'll see we're going to draw price increase. And you have to realize that surplus and shortage is here. Got that?
Oh.
There's a good trade. I put it away for now. Okay. All righty. Okay. So that's just explaining. This is a. Oops, can't see that. So on your notes here, this is the correct supply and demand curve, where you got price is on the y-axis, quantity is on the x-axis. Okay, but the problem that you're going to see in your math book, they've got it backwards. All right, so it says, in this case, the market for a product is said to be in equilibrium when supply equals demand for a certain product with a unit price P. The supply and demand functions are given below. Write down an equation that can be solved to find the equilibrium price. So to find the equilibrium price, we want to set supply equal to demand. So we want to say supply equals demand. So we take those two equations and we set them equal to each other. Where do they intersect? All right, so this is going to be 2P plus 4p squared equals 1536 minus 30. Okay, now you would solve that by, in this case, we're going to use completing the square. B, that's our equation. All right, now to complete the square, what we want is we want our quadratic term and then plus or minus our linear term. And then on the other side, we want the constants. So what I have to do is just rearrange this so that I've got those terms on the correct side. All right, so there's my quadratic term. Okay, 2p is my linear term. Okay, and now what I'm going to do is I'm going to add 30p to both sides. And now I'm almost ready to solve it. 32p equals 1536. Okay, so now I've got it set up the way I want it. So now I can complete the square. So I'm going to divide by 4, get rid of that coefficient. P squared plus 8p equals 3. And now complete the square. So I'm going to take half of 8. 16. P plus 4 squared. Okay, so let's see. Square root everything. Plus or minus 20. So I end up with negative 4 plus 20. Okay, so that would be $16, or negative 4 minus 20. You would pay people to take the product. Negative $24. So you go buy it and you get $24 for taking it. That doesn't make any sense. The price isn't ever going to be negative. Okay. So the equilibrium price is $16. And if I plug their equation, the one on the left or the one on the right, it doesn't matter. I can get what the equilibrium quantity would be. Okay, so I'm going to take the 16 and just plug it into the second equation. It's a little simpler. So 1536 minus 30. It's 480. This would be 1000, which is where this point is right here. Okay, so this is the price here. This is the quantity. So at $16, quantity demanded and the price demanded, or the supply demand, would be equal. Okay, and then all I did was just type these two equations into Desmos. This was one equation. Okay, over here on the, I put this equation in, and this equation. So right here. And then I just look, where do they cross? And that's my, so that's how you would do the same thing on Desmos. Alrighty? Okay, so tonight, if you haven't started it already, okay, you're doing these by completing the square. Okay, now the last one is the same as what we just did. Okay, but it's talking about revenue and cost. So I'll just help you set it up. Okay, a publisher of a newsletter uses the following models to estimate monthly sales. So that's revenue. That's how much you get from selling your newspaper. Okay. Then there's the cost of making the newspaper. Okay. And here, these two formulas give you the revenue and the cost based on the number of people that subscribe to the newspaper. So X is the number of subscribers. All right. C and R are both given in thousands of euros. The value of X for which the revenue and is equal to the cost. So like you student council folks, you knew there was a certain amount of tickets you had to sell in order to cover the cost of putting on the dance. So your ticket sales were your revenue. Then the cost was renting all the equipment and the big mushrooms and all that good stuff. And then when these two meet, you broke even. And if your revenue was above your cost, then you made money. All right, so it says write down an equation to find the break-even point. So you're basically just setting these two equations equal to each other. Okay, now it says complete this by completing the square. So when you complete the square on this, you're going to be dividing by 0.25. So when we want to get rid of this coefficient, look up here, you have to do this. Okay, that is the same as multiplying by 4. This is really dividing by 1/4. Dividing by 1/4, same as multiplying by 4. Yes. You would be dividing by negative. All right. So now you're going to do just like what we did. Get the linear and the quadratic on one side, and then the well, there are no constants. Oh yeah, there is 300 on the other side. All right, and we'll check that tomorrow. You're doing A, B, and C. Okay, so you did that. You have 30 plus or minus 10 root 3. 20 and 60 root 3. 20 or 60. Oh, let's see. Break even. 20. What is, no, that can't be right. 30 plus or minus 10 root 3. There's no way that's equal to 20. Okay. So let's see. Divided by 2. Right there. And then half of that is going to be 1/4 squared. Okay.